Alright, so here we are evaluating a circuit, and since this circuit has no, it doesn't split or join together, we know that this is a series circuit. Alright, it only has one path. These, the volts here, 6 volts, this is a battery. The long end is the positive side, the short end is the negative. Positive, negative, so we have two 6-volt batteries here. Now we always start with 0 volts at the end, and here we have added 6 volts, so we have 6 volts here, and then we have added another 6 volts, so at C we have 12 volts. Alright, and then as we go along through these resistors, we have what we call a voltage drop, and we end up with 0 volts at the end. Now, even though our voltage changes and we have a different set of resistors, our current is the same throughout. Okay, so it says if the 10 ohm resistor is replaced with a wire, how would the current change? So if this was taken away and we just had a wire here, we would have no voltage drop. And you guys might have noticed in the lab, if you're not going through a battery or going through a resistor, your voltage stays the same. So if we took this resistor away, the equation for current is I, current, equals our voltage over our resistance. Guys, remember that the units for current are amps. Okay, so if we took away some of the resistance, if this got smaller, our current would increase. And it would increase all the way around because our current is the same throughout. Alright, C. If one of the batteries is replaced with a 3-volt battery, how would the current change? So if we took one of these 6 volts and made it a 3 volt, we're decreasing the total voltage. Now if we decrease what's on the top here, our current will also decrease. So it would decrease. Alright, so it wants to know the total current. Well, the total current will be our total voltage over our total resistance. Our total voltage is 12. We add up our two batteries and we get 12 volts. And our total resistance is 10 plus 8, which is 18. And then 18 plus 3, which is 21. Right, so we'll go ahead and plug that in. 12 divided by 21 is 0.57. So we have 0.57 amps of current going through this series circuit. Alright, what is the voltage used by this 10 ohm resistor here? So I'll go ahead and switch colors. We have a 10 ohm resistor here, and it wants to know what is the voltage. Well, our current, it does not change. So we can actually manipulate this formula to find the voltage there. We would just move our resistance over, we would just multiply both sides by the resistance. That would cancel out, and so our voltage at that point would equal our resistance and our current. Well, our resistance is 10 ohms. That's the resistor we're going through. And our current, we already figured out, was 0.57. So this resistor uses up 10 times 0.57, or 5.7 volts. Alright, now it wants to know the voltage at D here. Alright, and we're not done with this 5.7 volts. That's how many volts this resistor is using. So what we have to do now is, let's pick a color, maroon. We start out with 12 volts, and then this resistor used up 5.7. So to find out how many volts we have it at D after that first resistor, we have to subtract 5.7 from 12. So 12 minus 5.7 is 6.3. So we end up with 6.3 volts here. at D. So we have a voltage drop and it drops to 6.3 volts. Now we should be able to continue along here and figure out how much we're losing with this 8 ohm resistor. So 8 ohms, we'll find out our voltage by multiplying, just like with this. We can find our voltage by multiplying R by our current I. Okay, which is our resistor here would be 8 ohms. And our current is the same throughout, so it's still 0.57. Okay, so 8 times 5.7, or 0.57, excuse me, and we get 4.56. So we have 4.56 volts that this resistor is using up. So we have to subtract 6.3, or subtract 4.56 from 6.3. So 6.3 minus 4.56 gives us 1.74. So at letter E, we actually have 1.74 volts here. Alright, now to find the voltage drop from here, from E back to A, you guys should be able to make a prediction about how much voltage this uses up, since we have 0 volts over here on the other end. But our voltage that we use is going to be equal to our resistance, which is 3, times our current, which is 0.57. Okay? And when we multiply this together, we should get 1.74, because that's what we'll be subtracting to get our new voltage. So 3 times 0.57, and we get 1.71, which we must have rounded somewhere, but we end up with about 1.7, which is the same. 1.7 volts. Alright, so we end up again with our 0 volts over here. And it just goes along in this circuit.